Hello, fabulous sixth graders. This is Miss Laverde coming to you, and I wanted to come to you and discuss chemical bonding with you. So, I know we haven't had any classes, and I told you there wouldn't be any live, but I'm going to try to come to you as often as I can and go over our lessons with you so that you get some help outside of just going through the online middle school. So let's talk about chemical bonding. So let's think. What is a chemical bond? Imagine that you need to attach two pieces of paper together. There could be three ways you could do this. What are they? Yep, you could glue them, you could stick them, you could fold it together, you could staple it together, right? There are so many different ways that we can put two pieces of paper together. Some are often stronger than others. Our atoms are the same way. They attach together to form compounds in different ways. We call these attachments chemical bonds. Don't forget, you should have already learned in your lessons that atoms are made up of a nucleus, which have protons and neutrons, and they have an electron cloud. And these are electrons, they have shells that hold negatively charged electrons. And those shells hold what are called valence electrons. And the valence electrons are the electrons located in the outermost shell, and these are the ones that we use when we're talking about bonds. So let's talk about valence electrons. First, you can find out valence electrons by looking at the periodic table. This group right here, this group 1, they have one valence electron. And this group right here, if you can see my mouse, 2, has two valence electrons. This group over here has 3 valence electrons, 4 valence electrons, 5 valence electrons, 6 valence electrons, and 7 valence electrons. Now, these elements over here actually, except for helium is the exception, they actually have 8 valence electrons, and they are considered to be completely stable because their outer shell is completely full. Okay, so let's think about a few things. Electrons located in the last electron shell of every atom are what we call valence electrons. They're happiest when they have a full outer shell. The first orbit outside the nucleus can hold 2 electrons, and beyond that, every orbit can hold up to 8. These outer electrons, the valence electrons, are what we use to form bonds and create new compounds. So, as I just showed you, you can use your periodic table, group 1, group 2, group 3, group 4, 5, 6, 7, and 8 to find out how many valence electrons an element has. The atom with electric configurations of 2, 8, and 3 is aluminum. You can find it on group 3 of the periodic table. So let's look at this, aluminum right here. The first shell is going to have 2 electrons. The second shell is going to have 8, and the third one is going to have 3. Okay, so chemical bonding. What exactly is it? Well, it's the attraction between 2 or more atoms to form a chemical compound. There are 2 types of chemical bonds. One is ionic, the other is covalent. Let's talk about the 2. Ionic bonds is a bond in which one or more electrons are given away or attached to another atom. Okay, and these are made up of cations and anions, which you don't really need to worry about quite yet. Okay, then you have covalent bonds, and this is where your atoms are sharing the electrons. They're being friends and saying, hey, if you come over here, I'll share my teddy bear with you. Okay, so our covalent bonds are made up of nonmetals only. So let's think about this. Ionic bonds are where we give away our electrons. We're going to give our friend our teddy bear or our candy bar. But covalent bonds are where we share. We are going to get gold stickers with our friends because we are sharing if we are creating a covalent bond. So ionic bonds. Ionic bonds are forced through the attraction of positive and negative ions. They're formed when an atom lends or borrows electrons from each other. Metals lend electrons, and nonmetals borrow electrons. Ionic compounds usually involve a metal and a nonmetal. So, back on that periodic table where we said we had a certain number of valence electrons, this is going to let you know how many they can receive or how many they can give to become stable, because our outer shell, those valence electrons, you can have up to 8. So we want to get them to 8 so that they're stable and not angry anymore. So let's look at table salt. Table salt, you know, the white stuff you put on your food, it is made from sodium and chlorine. Sodium and chlorine bond to form salt. This right here is a sodium atom. It has 11 protons and 11 electrons. Chlorine has 17 protons and 17 electrons. This outermost shell, sodium has 1, and chlorine has 7. So sodium is going to give its electron over here to chlorine to make it stable. They're going to give it. Sodium's going to say, hey, buddy, I want to make salt. So I'm going to give you my electron, and you're going to have 8, and we're going to come together, and we're going to make salt, and we are going to become stable. That's how it works. Pretty simple, right? So you got a metal and a non-metal combining here to make sodium chloride, salt. Okay, so let's keep going. So ionic compounds. Ionic compounds have very high melting points. They're often brittle and can break along what we call a plane of cleavage. They dissolve well in water, and the water solution will often conduct electricity. Ionic bonds are made up of ions, cations, and anions. Ionic bonds will give away their electrons, and typically these type of bonds take place between metals and nonmetals. Charged ions bond to form a neutral compound. Remember, we want it to be stable. We want it to be happy. We don't want it to have this extra electron or a hole where an extra electron can go. We want it to be stable. We want it to be neutral. Ionic bonds are the strongest type of bond, and the number of valence electrons in an atom will determine how reactive it can be to another element. So covalent bonds. Earlier we said covalent bonds were non-metal bonds, right? They only form from non-metal to non-metal, and if you notice here, a covalent bond, they share the valence electrons. They're being good friends here. They're sharing, okay? But the valence electrons are weakly bonded, and this weak attraction between the nuclei and the shared electrons binds the molecule. So these are only your nonmetals. So let's talk about how oxygen and hydrogen bond to form water. Oxygen here has 8 protons, 8 neutrons, which means it has 8 electrons. But if you look here, the first orbit takes 2, and there's 1, 2, 3, 4, 5, 6 left in that outer shell. The outer shell should hold 8. So guess what? It's not exactly stable, is it? So then we have hydrogen. Hydrogen has 1 proton and 1 electron. Like the typo there, that's supposed to say neutrons, but 1 electron, right? So hydrogen's going to bond over here and give them 1, which makes oxygen have 7, but it needs 8. So we have to bring in a second hydrogen, and that's how we get H2O. So oxygen needs to have 2 valence electrons to be stable. Hydrogen needs 1 to be stable. So we end up duplicating that hydrogen. So there you go. 1 oxygen will then bond with 2 atoms of hydrogen, and all 3 share electrons. And as long as the electrons are shared, the outer shell is full. Nonmetals also bond to form molecules. The simplest type of molecule is a diatomic molecule, meaning it's made from only 2 atoms. There are only 7 elements that are diatomic: hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine. But molecules, they can get pretty complex. They can involve different elements. And remember, only those covalent compounds are going to contain nonmetals. Covalent compounds often have low boiling points. Most do not dissolve in water, aka oil and water don't mix. And if it can dissolve, the solution will not conduct electricity. These are all important properties to know. So definitely pause this video and take some notes while you're doing it. So let's think about covalent bonds. Key points. They are nonmetals only. They form uncharged molecules, and they are the weakest type of bond. So how does a molecule form? Go ahead, write it down. Which is stronger, an ionic or a covalent bond? What is an ion? Which type of bond typically has a higher melting point? And which type of bond involves only nonmetals? Go ahead, write that on your paper. Make a note. It's really important that you know that information. If you don't know the answer, go back and review this recording again. Okay, so here's a little wonderful little thing. I will send this out in email. Actually, I'll put it in the announcements. I will copy this link and put it in the announcements with this recording so that you can go and take this little fun Quizlet to learn about bonding. All right, so that's going to be it for now. I don't want to overwhelm you with our very first lesson. Once you finish watching this video, go to this website. Again, I will put it in the announcements, and you can go ahead and watch a little bit about covalent bonds. All right, I'll see you next time. Thanks, guys.